Hi, here's the question. Find the root between nodes. Given a directed graph, design an algorithm to find whether there is a root between two nodes. In this example, or in this question, we could use a graph traversal algorithm to find the path between two nodes. It could be breadth search or depth search. In this example, I'm going to use breadth search. And since it's a directed graph, there's a possibility that the graph will be pointed back to the root or to the higher level in the trees. In this case, we need a data structure to store the visitor node. In case we traverse it again, we could just ignore that. So here is what I'm going to do. So use a data structure, a set maybe, to save the visitor node. And use breadth search to find the path from start to end. So during the process, I need to create a queue to save all the nodes that I need to process. And at the beginning, I need to pop a value from the queue and check if it is equal to the end node. If that's the case, we could return true. So if it's not equal to the end node, we could continue with the traversal. So we check if the node is already visited. If yes, we can skip that. If no, we can add that node to the visited list or set, and add its neighbor to the queue for further processing. And at the end, if there's nothing in the queue, we could assume that if there's nothing in the queue, that means we cannot find the end of. We cannot find the path to the end. So we return false. Find the path at the end if there is nothing to pass. So let's start coding here. So I define a function called breadth search, and it take a graph start node and end node as an input. I need to create a data structure to save all the visited node. And I need to create a queue to save all the neighbor node. And we could use a library function here from connections, import dqueued, which is a queued with both direction. You could get it from the beginning of the queue or from the end of the queue. So could add the first element to the queue. So whenever we have something in the queue, we process or traverse the load. We pop a value from the queue by using pop left. And then we check if the node is equal to the end node. If that's the case, we can return true. We also check if the node is in the visitor set. If it's not in the visitor set, if it's in the visitor set, we could skip it. But if it's not in the visitor set, we need to add it to the visitor set. And add its neighbor to the queue. So it should be node. At the end, if we cannot find any path to the end, we return false. Okay, in here, we can define a function or call the function return BFS search graph node 1, node 2, and we can check the result here. Yeah. So in summary, what I've done is to use the BFS search to find the path from start to the end. I use a data structure set to save the visited node. In case the node has been visited, we ignore the and we continue the transversal. And I use the queued, which is a first in, first out data structures. We push the labels to the queued, and then get the first one which push to the queued, and process the first one which push the queued first. It makes sure that we process all the higher level node before we process to the next levels. So at the end, if we cannot find the path to the end, we return false. Hope it will answer your questions here. Thank you. Bye-bye.